So good morning, I'm Tom Kelly, Automation Alley Executive Director and CEO, and welcome to Industry 4.0 in Focus. This is our weekly virtual event series dedicated to the fourth industrial revolution. Each week, we're taking a deep dive into topics covered in Automation Alley's 2020 Technology and Industry Report. This week's topic, 3D printing's impact on the supply chain. I'm pleased to be joined by Dr. Peter Warrow. He's the Director of Applied Research and Development at St. Clair College. Peter's here to talk to us about the research he did for our 2020 tech report and how disruptive this additive manufacturing technology can be to traditional manufacturing methods. So welcome, Peter. Thanks for being here.
Thanks for having me.
Glitches and all, right? The sign of the times. I'm waiting for like my kid to run by or a dog to come in and start barking, but hopefully we're behind the issues. So for our live stream viewers, if you'd like to ask a question, please do so using the Q&A function below. I'm hopeful that it will work and we'll be able to get your questions because it's really important. And if you're an Automation Alley member, you can download a free copy of the 2020 Tech and Industry Report via the resource tab in the member portal at automationalley.com. So Peter, let's get right to the questions. Additive manufacturing is not a new concept. It's been around a long time. But we've seen recently the impact it can make as we witness 3D printers coming to the rescue to churn out critical PPE during the pandemic. Why was 3D printing the technology we turned to during the crisis?
I think the main reason is because it was quick. People just basically, if they had a design, they could send that design to the 3D printer and have a product right away. In fact, it was almost chaotic because there were so many designs that were floating around on the internet and sharing of designs, which is great. There's so many people that were stepping up that wanted to help out during the pandemic that everybody was trying to help out. And having that opportunity to send a CAD file to the 3D printer and have a product within hours, if not sooner, was really the main driver for this. So it really bridged that gap between having these big volume parts that are made to small batches that can get out to the market very quickly.
Excellent, excellent. So what lessons are there that we can glean from this COVID-19 pandemic as far as technology considerations manufacturers can take to be prepared for future disruptions?
Well, I mentioned there was a bit of a chaotic scene initially because there's so many companies, so many people, individuals that were trying to get these parts made up. And I think having a strategic focus and understanding how does 3D printing or how does additive manufacturing fit into this overall manufacturing process is really important. So it's not really a technology, but more of a process flow. The other thing that we ran across was materials. So especially materials for the medical industry, and having that understanding about the material properties and what materials are best suited for medical devices was really important. So having that knowledge ahead of time can really prepare us for the hopefully if we don't have another pandemic, but if we do have to be prepared on the materials and the process flow.
Yeah, you're right. Boy, this has been tough on everybody, but it's really a time where additive really has shined through all of this. So if I think about manufacturers that are using subtractive methods to produce goods, i.e. what we do today, it's a fancy term for the way we make products today, subtractive manufacturing. They can't just flip a switch and go right to additive. What do manufacturers need to think about or do to begin this transition? Because, well, first let me ask you a two-part question then. How quickly do you think this transition is coming? I'm a small manufacturer, I'm in manufacturing, I'm doing subtractive manufacturing. I see this technology coming. How quickly do you think this technology is coming? And what do I need to be doing to make sure I can make this transition?
That's a challenge because I think small manufacturers are utilizing 3D printing. A lot of it is in prototyping. So it's being utilized and they're making prototypes and they're making fixtures, they're supporting their production processes, but not necessarily manufacturing parts for production, at least with small manufacturers. The large OEMs, they are, but the smaller manufacturers, I don't see that happening. And from my experiences, when I interact with local companies, they see the benefit, but they don't understand how to integrate it. And I think that's the biggest, stumbling block is how do you integrate your additive processes in your traditional subtractive manufacturing? And I think that's where, we've got to get over that hurdle. So I guess to answer the first question you're asking is, how do we can't flip a switch? Well, we have to practice, and companies have to start experimenting and seeing, well, where are the advantages? Where are the applications that we can integrate additive manufacturing into our traditional processes, and start experimenting with that and look at the ROIs and see, well, what are the advantages of having additive and integrated into our subtractive manufacturing?
Yeah. So then based on the question that you just answered, which was a good one, how does the supply chain get impacted? So in other words, I got an OE, tier 1, tier 2s, tier 3s, tier 4s. There's a whole supply chain. What happens in that supply chain, and how does additive fit in or disrupt what we know today?
So again, it depends on what your application is and also the industry. So if you're prototyping, I don't think it has much of an impact on your supply chain. It'll help accelerate your getting your parts to production, and it'll decrease the amount of time it takes to get there and the amount of challenges you have with production parts. But I don't see it affecting the supply chain. Where it starts affecting the supply chain is where you start getting into small batch production. So once you start integrating additive manufacturing into your traditional manufacturing processes, if you have, let's say, for example, a complex part that traditionally it might have been 2 or 3 or 4 parts that had to be sub-assembled, and now additive manufacturing can manufacture that in one step, well, that might start eliminating some of your suppliers, or at least reducing your suppliers. The other thing that happens is, or that can happen is, what happens is you'll get a distributed manufacturing supply chain. So you'll have your suppliers that are closer to the customers because they directly manufacture and ship to those customers. So you want to be closer to those customers. So you might have a physical relocation of the supply chain.
Gotcha. So will you see then in this whole transition that suppliers may end up with more facilities that are smaller and agile, closer to their customers? Or will we continue to have big aggregated facilities with lots of printers in them, doing lots of different things?
That's a good question. And I think you might see a little bit
or a little of both.
and I think one of the things that at least I've found with printers is they're very specific in terms of what their target is. So you might have a facility that has many different types of 3D printers, and because they are very specific in what you're trying to produce. But again, you're going to see, I think, potentially more or smaller suppliers that are located closer to the customers. And again, I think it depends on the industry and what your product actually is.
Gotcha. So let's take this moment right here, this point in time, with the materials that we know are available, with the materials that are capable to be printed on 3D printers. Which industries are best suited to sort of begin this transition to additive manufacturing?
I think you're seeing it already in the aerospace industry. You have aerospace companies that are already manufacturing production parts that are going into airplanes. So you're seeing that with the different types of materials. And the nice thing about the aerospace industry is again, the volumes aren't as big as, say, automotive. And that's where 3D printers are best suited at this point in time. You're also seeing it in the medical device industry. The nice thing about 3D printers is you can customize, so that mass customization is possible. So people just are very different anthropometrically. So if you have medical devices or medical products that are geared toward specific anatomies, then you have that opportunity. And the materials are such that we are starting to get materials into living tissue or living bodies. So we're at that point.
So it sounds like what I heard was high value products, low volume. That's a sweet spot. Anybody who's in that business, I make high value products, low volume, small footprint. I should be definitely looking at additive at this point, right? At
Absolutely.
least looking.
Yeah, and that's where you're right. That's the sweet spot. So that's where additive is really, really good. So when you look at I talked about, the speed with which people were able to get products printed for the pandemic.
Mhm.
And that's one of the challenges, though, is if you have high volumes, it's not as fast as if you have a molder, for example.
Sure.
Or if it's low volumes, then that break even point for the ROI could be much better for additive, because you have small volume that your printers are really geared towards.
So talk to me about standardization, right? One of the things I hear, one of the criticisms in this wild west of additive and all the, the top 10 printer companies all doing their own thing, all creating different standards on how they want to make parts and how their machines work to lay down material. What do you think about standardization? What are your thoughts on it, just in general? How do we frame it? Because I bet this is a new concept to almost all of our listeners, what the standardization track looks like for additive. And then what types of standards are we talking about that you think are critical for people to pay attention to, that we need to focus on?
Yeah, so when you look at traditional manufacturing, we have our design for manufacturing guidelines, and we understand we've been doing that for decades, if not longer. When it comes to additive, it's an open slate. So when you have a really a blank slate where you can create something out of nothing, essentially. So there's the design for additive manufacturing processes is not necessarily something that we've figured out that well, and which is a good thing in a sense, because you have so much creativity. You can attack a problem from many different ways. You can look at different types of designs and different opportunities for design, things that we've never even thought of. But having some sort of standardization in terms of having some guidelines with respect to design for additive manufacturing would be important. And when it comes to different types of printers, so printers, as I mentioned earlier, they have more or less specific applications that they're really good at. Others are good at other things. So having some kind of standardization around those particular aspects are good, and including material, including tolerances and things like that. So and repeatability. So those kinds of standards, I guess, would be really important for the additive community.
Is one of the things that slows down 3D printing, not only do you need standards, but if you're doing like for like on products, you have to, there's a lot of body of knowledge in materials science, in how subtractive works, and they've glued things together and they've riveted things together and they've done all these things, and they know how it breaks and they know when it breaks, and they know so much about the academics of it all. And in 3D printing, you're like, well, I'm not really sure I understand fully how this part can fail or what the problems are. Is that also coming along, Dr. Waro? Is that getting more mature in the industry?
I think that's the next step. So when I started getting our college involved in 3D printing, we were working with companies and mostly smaller companies. And initially it was print me something that's already done, and we're just going to compare. And it was really more of a fit and feel kind of thing. Then they started saying, well, let's look at different types of design. How can we make this better? And so we started doing that. Now we're really getting to, well, now does this part work in the real world? And looking at the material properties, and especially when it comes to metal, for example, we can print, steel, stainless steel metal products, but does it perform the same way as stainless steel products that are subtractive manufactured? And I think that's where we're going. We're looking at material properties and doing some testing and understanding that. So are we there yet? With respect to the small and medium companies, maybe not necessarily. Again, I don't know the insights into the large OEMs, but I think we're starting to understand, we need to do this type of research and understand how does this perform in the real world.
Excellent. Yeah. So can you give us an example of an innovative company that's kind of doing this? I guess innovative is a subjective term, but let's assume someone has made the transition to additive. Do you have an example of a company that's done that?
Sure, I'll give you two actually. So Boeing, I mentioned the aerospace industry is they're farther along, and they're doing a lot of these additive manufacturing. So Boeing in the 787 Dreamliner, they actually have about 30 parts in production, like on the airplane, that are 3D printed. and those go from different types of hinges and things like that.
Mm-hmm.
Ford is another example. The Mustang, they actually print the engine cover, or 3D print the engine cover for the Ford Mustang. And I actually had the, and I'm sure, as I said, most, if not all OEMs are getting involved, especially in the automotive industry, are doing 3D printing. But I had the opportunity to visit one of the Ford facilities where they're looking at advanced type of products and things like that. And they had essentially a warehouse full of different types of 3D printers. And so they're really experimenting and innovating and seeing how they can start integrating that those processes into traditional manufacturing.
Yeah, and one of the ones maybe you could comment on that I hear about. So I hear about like Ford printing the engine cover. So not mission critical. They can, if the fit and finish isn't perfect, that's okay. We're learning. But there's a company, obviously, GE really on hard times these days, but they're 3D printing the jet fuel nozzle for the jet engine, the most critical component, because it created such an innovation in terms of fuel savings and what they could do. What do you make of that, where they're actually doing the mission critical production part for GE jet engines?
Yeah, and that's a good point. And GE was another one that I've seen as being an innovative company, and I think that's fantastic to see how they can actually now look at like you said, a mission critical part and put it into production. So obviously the maturity of additive is getting to the point where we're starting to see, based on the complexity of parts and the materials, that we're able to actually put these critical parts or components into production.
Yeah, and I understand one of the harshest environments on Earth is the inside of a jet engine, right? So if 3D can stand up to the and the FAA can actually clear that part for use, then there's nothing that can't be done, apparently.
Right.
It's just we haven't culturally arrived at the will and the courage to actually do it, right? Or perhaps the money, the ROI, that you can make them enough of them and that kind of thing.
Yeah, and it comes down to, like I said earlier, the experimenting, the trials, and seeing, well, what can we do? What can we, advance in terms of our production? And I think the biggest thing, and that's, I guess the main point of our topic is the supply chain. How does that affect the supply chain, and how do we integrate that part now into, into that production process throughout the supply chain?
Point well taken, right? So based on the conversation we've had, where do we go from here? What's the industry look like 5 or 10 years from now? I mean, what'll I be talking to you about in 2025 that we didn't foresee coming in 2020? I mean, I'm not asking you to be Karnak, but what do you think?
Sure, I'll look at my crystal ball.
Right.
Yeah. I think,
and then tell me the stocks that will do well based on your knowledge, right?
Right. This is based on my experiences, what I'm seeing, and I see two different things happening. One from smaller startup companies. I see them popping up, and more of them playing a bigger role in terms of quality parts and innovative type of products. And I think we're going to see more and more of that. We're going to see smaller companies, more or less mom and pop shops that are basically just producing things that we never thought possible. So I think you're going to see that from that perspective. And I guess if we look at automotive or any kind of manufacturing, you're going to start seeing, I believe, the trickle down effect of additive. So right now, I think the OEMs are really engaged and practicing and experimenting and doing all kinds of neat things and innovating with additive manufacturing. I think that's going to start trickling down to the suppliers. And what I see around here is, as I mentioned, there are suppliers that are interested and they see potentially the benefit, but they don't understand it yet. But I think there's going to be that some company or companies are going to start looking into this and start really advancing their processes, and it's going to create competition. So other companies are going to jump on board and start experimenting with it. And I think that having universities and colleges participate with them, I think is going to advance that even quicker.
So, good answer, by the way. But let's turn our attention to academia, because in the academic world, do you think we're doing enough to prepare the future workforce for jobs in additive and 3D and just industry 4.0 fields in general? What can be done to make sure the academic world gets it, gets the pace of change and how much is happening out there. What do you think we need to be doing to make sure the talent pipeline is full, so to speak?
Well, let me start with where we are right now. And I see a lot of academic institutions, they all have 3D printers. Labs will have them for their, let's say, their project work, and you're able to print things out. But they're often in a little lab kind of thing, and we're printing things, and we're not really understanding. And we also have, but we do have researchers that are doing research in additive and looking at different material properties and things like that. Where we don't see it though, I don't see a lot of it is in the actual curriculum. So we take a traditional engineering program, manufacturing engineering, electrical, mechanical, whatever it is, and you don't really see, or at least I haven't seen, the integration of additive in those programs, and because we're still in that mindset that this is how we've done it all these years, and we haven't we're not ready to change yet. So it's almost like a chicken and the egg, because do you wait for the industry to start forcing the issue? You have the post-secondary institutions start looking at, well, we're going to start integrating additive into our programs, and that's going to create a whole new workforce. But I think that's really where we need to go, is start understanding from the academic point of view, how do we now integrate additive manufacturing in our traditional programs and in traditional curriculum?
Yeah, very, very good. Very good. Well, so this was a great conversation. Dr. Waro, thanks for joining us today. I think it was a great conversation. I always learn something about additive. I really think it is the future. It's just a question of what that curve looks like. It's going to be exponential, but as we know, both you're an engineering academic. I'm a former engineer, not a practicing today. I left that a long time ago, but exponential curves, they seem to bounce along the bottom at zero for a long time before they go vertical. And it happens very quickly, right? So we have to pay very close attention. And I think all your comments were very enlightening, and I appreciate you very much for being here.
Thank you for having me.
You bet. So for our viewers today, I know we had trouble today. I deeply apologize for that. I hope that this you can go back and watch this. If you were not able to join us, you're able to join us again. This will be archived. It did record, and so we'll have it up on our website. Please join us again next Thursday, September 10th, for a discussion on data protection and security in the Industry 4.0 era. Thanks, everyone. Have a great day. Thanks, Dr. Waro. Thank you.
Thank you.